All right, let's dive right into this. Welcome to today's explainer, where we're going to unpack the high-stakes, intensely logistical world of offshore engineering. Specifically, we're focusing on something that is absolutely fundamental to the entire offshore industry, the support vessels. These aren't just boats, they are highly specialized lifelines. Without them, extracting resources from beneath the ocean floor literally wouldn't be possible. I want you to think about something for a second. An offshore platform is basically an isolated, heavy industrial city parked in one of the most hostile environments on Earth. It has massive power generation, accommodation blocks, heavy machinery, and this constant, unending need for supplies. But there are no roads. You can't just drive down to the hardware store when a pump breaks or wait for a standard delivery truck when you're running low on gear. When a platform is burning through drilling mud or needs a massive new piece of equipment, or, God forbid, faces an emergency that requires immediate evacuation, there are literally only two ways in or out: helicopter or boat. And while helicopters are fantastic for moving personnel quickly, the heavy lifting, the absolute vital lifeline for materials and large-scale safety, relies 100% on the offshore support fleet. Understanding this fleet is the key to understanding how offshore logistics actually work. So let's move through our visual roadmap and see how this all builds. We'll start with the concept of the isolated island city. Then we'll break down the freight trucks, the heavy hitters, the guardians, and the specialists, before wrapping up with how all of this is managed at the supply base. Okay, part one, the isolated island city. I really love how the source material frames this. Every offshore platform is an island. It can't drive to the hardware store. An offshore installation just isn't self-sustaining. It's actually the beating heart of a massive dynamic logistical network. If you cut off that constant flow of materials, the whole operation grinds to a halt. And without a constant protective presence around it, the crew is dangerously exposed to the elements. Moving on to part two, the freight trucks of the sea, platform supply vessels, or PSVs. You can always spot a PSV by its distinctive profile. They have this really high bow and forward superstructure built specifically to take a beating from severe weather. And if you look toward the back, you've got this massive open cargo deck. We're talking 70 to 100 meters long. It's basically a floating warehouse floor, perfect for stacking containers, drill pipes, heavy equipment, and chemicals. But here is the really fascinating part. What you see on the deck is only half the story. The real secret of the PSV is its hidden payload. Right below that massive deck is a complex, specialized system of tanks. These tanks carry the absolute lifeblood of any drilling operation: bulk liquids. We're talking drilling mud, base oil, brine, potable water for the crew, diesel fuel, and bulk cement. Now you might be wondering, how does this ship stay perfectly still next to a huge steel rig in the middle of crashing waves to deliver that cargo? It uses a computer-controlled system called dynamic positioning, or DP, and the crucial point here is redundancy, specifically DP2, meaning there are two completely independent DP systems. This is an absolute necessity, because while a giant crane is plucking heavy loads off the deck, a poorly secured container on a swing ship could instantly become a lethal projectile. The vessel has to stay locked on its coordinates no matter what the weather is doing. All right, part three, the heavy hitters, the AHTS vessels. This is the anchor handling tug supply vessel. If the PSV is your standard freight truck, the AHTS is basically a heavy-duty tow truck crossed with a bulldozer. These vessels are packed with immense engine power, specifically designed to tow massive semi-submersible drilling rigs and floating production structures across the open ocean. But for sure, their craziest job is wrangling anchors. Just picture this tension-filled scenario for a second. The AHTS has to hook onto a massive mooring chain, drag an anchor weighing 10 to 15 tons across the seabed to an exact pinpointed location, and then use the sheer tension of the mooring system to literally drive that anchor deep into the mud. And pulling them back out? That takes even more unbelievable power and skill, especially when a 15-ton chunk of steel has completely buried itself in soft ocean mud. Section 4. The Guardians, also known as standby vessels. You'll immediately notice the clearly marked rescue zone painted on the side of the Emergency Response and Rescue Vessel, or ERV. Now, this vessel carries absolutely zero cargo, none. By law, every single manned offshore installation has to have at least one of these circling the waters during normal operations. Its sole legal mandate, its entire reason for existing, is to save lives.
And the history behind them is incredibly serious. After the tragic Piper Alpha disaster in 1988, the Cullen Inquiry completely overhauled safety regulations. We stopped using inadequate converted trawlers and brought in these purpose-built rescue machines. They have to meet strict criteria now: minimum lengths, 10 knots of speed, 360-degree vision from the wheelhouse, highly maneuverable thrusters, and they have to carry 2 fast rescue craft.
When disaster strikes, these guardians have immediate response triggers: man overboard, life raft deployed, platform evacuation. They are instantly on the scene. To do this, they constantly hold their position downwind and down current of the rig, so anything or anyone falling into the water drifts toward them. They're also constantly monitoring for smoke or flooding, acting as the very first responders long before a helicopter could ever make it out there. Okay, Section 5, the offshore specialists. This roster is just wild. You've got well intervention vessels packing light equipment for coiled tubing operations right inside the well. You've got construction support vessels lowering massive subsea pipelines into the dark. There are diving support vessels, or DSVs, outfitted with ROVs, diving bells, and deck decompression chambers for deep-sea divers. And then you have seismic survey vessels towing acoustic hydrophone arrays that are literally kilometers long just to map the rock layers deep beneath the ocean floor.
And this brilliantly illustrates the sheer scale of what we're talking about here. Just look at the variety. It's like a giant, complex puzzle. Deep water extraction is only possible because all of these highly distinct, hyper-specialized ships are out there coordinating together in this massive maritime ballet.
Which brings us to Section 6, supply-based logistics, the onshore brain. So how do they keep it all straight? Well, managing this fleet is an entire masterclass discipline in itself. A single major offshore field might have 5 to 10 of these vessels operating continuously. All of this is choreographed from a shore base that could be hundreds of miles away. They juggle complex cargo manifesting, incredibly tight vessel scheduling, helicopter flight paths, and the complete logistical nightmare of rotating hundreds of personnel safely in and out. So I want to leave you with this thought. What does it actually take to choreograph this massive mechanical ballet from a shore base hundreds of miles away, especially when you know that a single missed delivery could shut down a multi-million-dollar operation, or worse, cost a life? The platform's reliance on this fleet is absolute. Understanding these vessels really is the foundation of understanding offshore survival. Keep that immense logistical challenge in the back of your mind, because in our next explainer, we're going to dive into how massive fixed steel jacket structures are actually installed, following their journey from the fabrication yard onto the transport barge and finally pinned right to the seabed. You definitely won't want to miss it.